25. Worst engines ever put in production cars. Hey, muscle car lovers, ever wondered which engines in automotive history earned the title of worst engine blunders? Some of these notorious power plants failed so spectacularly that they left their mark on the industry and the unfortunate owners who experienced them firsthand. From chronic oil leaks and blown head gaskets to overheating nightmares and underwhelming power, these engines represent the ultimate mishaps in automotive design. So, what went wrong with these engines? How did engineering flaws and rushed designs create a legacy of high maintenance costs and frustrated drivers? Join us as we dive into the 25 worst engines ever put in production cars. Get ready to discover if your least favorite engine made the list. And hey, let us know in the comments if you've had personal experience with any of these. Don't forget to like, share, and hit that subscribe button to keep up with Muscle Car Masters. Cadillac V8-6-4 engine. The Cadillac V8-6-4 engine stands as a cautionary tale, a most failed engine and one of the worst engine blunders of its era. Marketed as an innovation in fuel efficiency, it aimed to deactivate cylinders based on driving needs, shifting from a V8 to a V6 or even a V4. But Cadillac's vision far outpaced the technology. The computer command module, boasting 300,000 calculations per second, struggled to keep up with real-world conditions, causing the engine to hesitate, lurch, and lose power unpredictably. Software updates couldn't save it. Cadillac attempted 13, but the deactivation system continued to disrupt a smooth drive, frustrating loyal customers and causing widespread disillusionment. The rocky transitions between cylinder modes were so jarring that many owners opted to disable the system altogether, reverting to a standard V8 setup. This failed experiment not only damaged Cadillac's reputation for luxury, but also set back variable displacement technology by years. Today, it's remembered less as a bold innovation and more as an example of rushing untested tech to market, leaving drivers stranded with one of the most unreliable engines of its time, Oldsmobile Diesel. The Oldsmobile Diesel stands as a symbol of GM's haste and cost-cutting gone wrong, marking it as one of the most failed engines in automotive history. Born from a desire to counter foreign diesel success and improve fuel economy, GM transformed its gasoline 5.7-liter V8 into a diesel. But this rushed adaptation ignored diesel's high compression needs, leading to head bolts that stretched under pressure, blown gaskets, and catastrophic engine failures. To save costs, GM skipped critical components like a water separator, exposing the engine's fuel injectors to low-quality diesel that rusted and failed frequently. Oldsmobile Diesels also inherited a weak 3-speed transmission, unsuited to the diesel's torque and the car's heavy weight, resulting in frequent breakdowns. Even basic operation was rough. The engine was underpowered, emitting excessive smoke, clattering noisily, and achieving sluggish acceleration, making 0 to 60 a drawn-out ordeal. These compounded failures earned the Oldsmobile Diesel a notorious reputation, sparking lawsuits and leading to the birth of the Lemon Law. Ultimately, GM's diesel experiment did more than tarnish Oldsmobile's image. It stained the market for diesel passenger cars in the U.S. for years, cementing its place among the worst engine blunders of all time. Chevrolet 2.2-liter OHV inline-4 engine. The Chevrolet 2.2-liter OHV inline-4, often called the 2200, quickly gained a reputation as one of the most failed engines in GM's history, due to its chronic reliability issues and lackluster performance. Originally intended as a cost-effective successor to the Iron Duke, it instead plagued drivers of the Cavalier, Sunfire, and small GM pickups with constant mechanical headaches. Head gasket failures were particularly notorious, causing severe coolant leaks, which often led to overheating and, eventually, engine damage if left unchecked. Beyond these gasket issues, the 2.2-liter was prone to excessive oil consumption, resulting in frequent misfires and rough idling that frustrated owners. Misfires, combined with a lack of power, made the engine inefficient and noisy, while struggling with emissions compliance. Yet, GM continued production for over a decade, hoping minor updates would redeem it. However, the 2.2-liter's reputation for being underpowered and unreliable overshadowed any improvements, leaving behind a legacy of costly repairs and a tarnished image among GM's compact car lineup. Today, it stands as a testament to GM's struggles during the era, a prime example of cutting corners resulting in an engine that consumers simply couldn't trust. Chrysler 2.7-liter V6 engine. The Chrysler 2.7-liter V6 engine ranks among the worst engines due to its notorious design flaws that led to costly failures and frustrated drivers. Introduced with hopes of providing a lightweight, efficient power plant, the 2.7-liter instead became infamous for oil sludge buildup, a direct result of coolant leaks from the poorly designed water pump gasket. This design flaw allowed coolant to mix with oil, turning it into sludge that clogged critical oil passages, starving the engine of lubrication and causing catastrophic damage. Many owners found their engines failing prematurely, some as early as 40,000 miles, often requiring full replacements. The sludge issue was so pervasive that it led to numerous complaints and class action lawsuits, tarnishing Chrysler's reputation.
Phil LeBeau joining us now with from Chicago with more. Hey, Phil.
Additionally, the 2.7-liter's underwhelming power made it a poor fit for heavier Chrysler and Dodge models, leaving drivers with sluggish performance and engines struggling under load. Although Chrysler attempted fixes, the damage was done, cementing the 2.7-liter as one of the most problematic engines in recent automotive history. Mitsubishi 3.0-liter V6 engine. The Mitsubishi 3.0-liter V6 engine, once celebrated for its smooth operation in vehicles like the Dodge Stealth and Chrysler minivans, ultimately became a worst engine blunder due to its notorious oil consumption and valve guide issues. This engine's Achilles heel was its valve guide seals, which deteriorated prematurely and allowed oil to seep into the combustion chamber. The result? Excessive oil burning and a trail of thick blue smoke from the exhaust, leaving drivers constantly refilling oil. Even more problematic, the valve guides themselves could slip, worsening the oil leakage. Attempts to fix this issue were invasive and costly, often requiring the entire head to be serviced or replaced. Additionally, the engine's design made it prone to sludge buildup, especially in cold weather, as the PCV system and valve cover drainage could clog easily. These frequent leaks and consumption issues overshadowed its initial reliability, transforming this engine from a promising performer into a costly maintenance burden for countless owners. Ford 4.2-liter V8 engine. Next on the list of most failed engines is the Ford 4.2-liter V8. Introduced as a fuel-efficient option during the early 1980s fuel crisis, this engine, also known as the Ford 255 V8, prioritized economy but at the steep cost of performance and reliability. With just 115 horsepower and 195 pound-feet of torque, it offered minimal power, leaving many drivers underwhelmed, particularly in vehicles like the F-Series trucks and Ford LTD, where more muscle was expected. The 4.2-liter's issues, however, didn't stop at low output. It was notorious for intake manifold gasket failures and head gasket issues, which led to coolant leaks, engine overheating, and, in severe cases, internal engine damage. Timing, chain wear, and carbon buildup compounded these problems, leading to costly repairs and frequent breakdowns. Ford tried to rectify some issues, but the engine's reputation as an underpowered and problematic V8 was already cemented. Ultimately, the 4.2-liter was phased out, replaced by engines that better balanced performance and reliability, leaving it as a clear example of a worst engine blunder. GM 3.1-liter V6 engine. Next up on our list of worst engines is GM's 3.1-liter V6, which proved problematic despite its widespread use. At first glance, this engine, found in models like the Chevrolet Lumina, Pontiac Grand Prix, and Buick Century, seemed like a durable, affordable option. However, as the miles added up, owners quickly encountered recurring issues, primarily due to its notorious intake manifold gaskets. These gaskets, made of weak composite plastic, degraded under heat stress, allowing coolant to leak into the engine oil, causing overheating and even internal engine damage if ignored. Additionally, the 3.1-liter faced challenges with the EGR valve clogging from carbon buildup, leading to rough idling, misfiring, and even poor fuel economy. As a result, drivers experienced costly repairs and frequent visits to the mechanic just to keep their engines operational. GM eventually made updates, but the damage to the engine's reputation was done. This engine, though prolific, became a frustrating investment for many. A classic example of an engine that might have performed well if not for its critical design flaws. Ford 3.5-liter EcoBoost. The Ford 3.5-liter EcoBoost engine, especially in its first generation, unfortunately earns a spot among the worst engines due to various reliability issues. At the core of its problems was carbon buildup, a common challenge in direct-injection engines, which led to rough idling, power loss, and misfires as deposits restricted airflow over time. Timing chain stretch was another persistent issue, causing a rattling noise and triggering performance problems that often led to costly repairs. Adding to the frustrations, many owners experienced condensation buildup in the intercooler, which caused misfires and hesitation, particularly in humid climates or under heavy loads. The turbocharged design also put significant stress on ignition components, leading to frequent spark plug and ignition coil replacements. Ford addressed several of these flaws in the second generation, but the initial models left a sour impression due to the high maintenance demands and unpredictable breakdowns. For many, the 3.5-liter EcoBoost represents a well-intentioned design undermined by execution flaws that landed it in the ranks of disappointing engines. Mazda 1.3-liter rotary engine. The Mazda 1.3-liter rotary engine, especially prominent in the RX series, exemplifies a worst engine blunder due to its reliability issues and high maintenance needs. Known for its unique design using rotors instead of traditional pistons, this engine offered smooth power delivery but suffered from rapid wear on its critical apex seals, leading to poor compression, power loss, and a significant drop in fuel efficiency. Excessive oil consumption compounded the engine's problems, making regular refills essential. The rotary's design also left little room for proper cooling, with narrow water passages that aggravated overheating and increased wear on the seals and rotor housing. The compact yet problematic engine frequently demanded costly repairs, with many owners needing full rebuilds after just 60,000 miles. Mazda tried to address these issues in later models, but the early rotary's inefficiencies and high running costs left a lasting mark. While innovative, the 1.3-liter rotary's notorious flaws positioned it as a classic example of a design that prioritized novelty over durability. Triumph Stag V8 engine. The Triumph Stag's 3.0-liter V8 engine, created with high hopes of competing with top GT cars, earned its place as a worst engine blunder due to a host of fundamental design flaws. Triumph's decision to avoid the reliable Rover V8 and instead twin their inline-4 into a V8 was disastrous. The widened cylinder bores consumed space meant for coolant passages, crippling the engine's cooling ability. Triumph also placed the water pump in the valley of the engine, driven by fragile gears prone to failure. Positioned above the radiator fill cap, the water pump setup made it nearly impossible to properly fill the coolant system, leading to frequent overheating. Further issues arose from the head studs being mounted at two different angles, causing cylinder head warping under heat. The engine's tiny main bearings and a stretched timing chain led to regular breakdowns, often resulting in catastrophic engine damage. The Triumph V8, despite its promising specs, became infamous for its mechanical woes, dooming the Stag's potential as a British GT contender and cementing this V8 as one of automotive history's great cautionary tales. GM 3.6 High-Feature Engine. The GM 3.6 high-feature engine, specifically the LFX and LLT variants, stands out as a worst engine blunder due to a series of recurring issues that plagued numerous GM models. A major flaw lies in its timing chain, which is prone to premature wear and stretching. This defect often triggers the check engine light, hood rattling, and, if left unattended, severe engine misfires and even catastrophic failure. Replacing the timing chain alone can cost thousands of dollars, making it a costly problem for owners. The engine also suffers from excessive oil consumption due to piston ring wear, leading to engine damage if oil levels aren't meticulously monitored. Additionally, carbon buildup on intake valves, a side effect of its direct injection technology, further deteriorates performance and efficiency over time. Frequent water pump failures result in overheating, adding to the already high maintenance demands. Despite its promising specs, these persistent issues have tarnished the engine's reputation, marking it as a costly, high-maintenance unit rather than the reliable powerhouse it was intended to be. Jaguar V12. The Jaguar V12 engine, used in iconic models like the XJ12 and E-Type, is often seen as a worst engine blunder due to its complex design and significant reliability issues. While impressive in concept, this 5.3-liter V12 suffered from a cooling system that barely managed to regulate its substantial heat output. The engine's intricate layout, filled with tightly packed hoses and wiring, made basic repairs daunting and costly. Additionally, the engine's reliance on the temperamental Lucas electrical system led to frequent breakdowns, while overheating issues were exacerbated by a sensitive cooling system that required precise maintenance. Fuel consumption was also notably high, making it an expensive choice to operate and maintain. Adding to these issues, the engine faced vapor lock problems, particularly in hot weather, causing it to stall or refuse to restart. Despite the allure of a V12 under the hood, these constant and costly repairs left many owners with a vehicle that was as much a burden as it was a beauty, solidifying the Jaguar V12's place among engines plagued by flawed engineering. Pontiac 2.5-liter Iron Duke engine. The Pontiac 2.5-liter Iron Duke engine, initially seen as a fuel-efficient solution, became one of GM's most failed engines due to its severe limitations. Designed during the oil crisis to meet emission standards and reduce fuel consumption, this four-cylinder engine was underpowered, producing only around 90 horsepower. As a result, it was particularly ill-suited for performance cars like the Camaro and Firebird, leading to slow acceleration and lackluster driving experiences. Further issues plagued the engine, including frequent overheating, cracking cylinder heads, and a noisy, vibration-prone operation that diminished driver comfort. In addition, the Iron Duke's timing gear was prone to chipping, leading to expensive repairs. Although the engine proved durable when used within its limits, placing it in sportier models led to widespread disappointment. And so, despite its longevity, the Iron Duke left a lasting impression as an engine with limited capability and lackluster performance, proving that sometimes reliability alone isn't enough to make a successful engine in a performance-driven market. Ford 3.8-liter V6 engine. The Ford 3.8-liter V6 engine, used widely across models like the Taurus, Windstar, and Mustang, earned its place among the worst engines due to persistent and costly head gasket failures. This notorious issue stemmed from the engine's mixed material design, an aluminum head paired with a cast iron block. As they expanded at different rates, the head gaskets were placed under excessive stress, leading to coolant leaks directly into the engine. As a result, overheating and significant engine damage were common, often before reaching 100,000 miles. Ford attempted to address these failures with an extended warranty on certain models, but the problem was so widespread that it led to repeated repairs and frequent mechanic visits. Additionally, signs like white smoke and coolant loss made the issue unmistakable yet unavoidable. Then, once overheating occurred, owners faced steep repair costs, sometimes exceeding the vehicle's value. This engine's high maintenance demands and vulnerability to failure cemented the 3.8-liter V6 as a classic case of poor engineering, frustrating owners with expensive and recurring issues. Ford Triton 5.4. The Ford Triton 5.4-liter V8 engine, once a flagship choice for F-Series trucks, stands as one of Ford's most failed engines due to chronic issues that frustrated countless owners. First, this engine faced significant timing chain and cam phaser failures, often indicated by a ticking noise due to insufficient lubrication. As the tensioners wore out, the timing chain would slacken, leading to misalignment and eventually engine failure. Then, Ford's problematic two-piece spark plug design in the 2004 to 2008 models made maintenance a nightmare. Spark plugs frequently broke during removal, leaving pieces stuck in the cylinder head, a costly repair often exceeding $1,000. Moreover, earlier models faced issues with spark plugs blowing out entirely due to weak threads in the aluminum heads. Additional problems like fuel pump driver module corrosion and ignition coil failures rounded out the list, leaving many owners to face recurring and expensive repairs. Despite its power, the 5.4-liter Triton became infamous for its maintenance challenges and reliability concerns, a true lesson in poor design execution. Toyota 3.0-liter V6 engine. The Toyota 3.0-liter V6 3VZ variant, used in models like the 4Runner and T100, stands as a worst engine blunder due to its persistent cooling system issues and underwhelming performance. A major problem was the head gasket failure, exacerbated by Toyota's shift from asbestos-based gaskets to less heat-resistant alternatives. As a result, coolant often leaked into the engine oil, leading to frequent overheating and severe engine damage if left unchecked. Drivers frequently reported problems before even reaching 100,000 miles, with the engine prone to overheating despite extensive maintenance. Additionally, the engine suffered from excessive wear on connecting rod bearings and cylinder head cracks, adding to repair costs. Compounded by a modest output of just 150 horsepower, the 3VZ's lack of power further disappointed those using it in larger, rugged vehicles. Despite Toyota's attempts at recall programs, the 3VZ's frequent issues tarnished its reputation and became a cautionary tale of cutting corners on durability, leaving owners with high maintenance costs and limited reliability. Chevrolet 305 V8. The Chevrolet 305 V8, designed as a fuel-efficient engine during the 1970s oil crisis, often ranks among GM's most failed engines for its limited power and persistent issues. With a small bore size and restricted airflow, the 305 delivered underwhelming performance, struggling to produce more than 170 horsepower in most versions. Though efficient for a V8, its design flaws quickly became apparent. Valve train problems were common, with the camshaft prone to wear that further reduced power over time. Additionally, oil leaks were notorious, especially from the valve covers and oil pan gaskets, leading to frequent and costly maintenance. While later versions with fuel injection improved efficiency slightly, the 305's lackluster power left muscle car fans disappointed, especially in performance models like the Camaro and Firebird. Although it remained in production for decades, the 305 ultimately served as a reminder that fuel efficiency alone can't satisfy drivers seeking robust performance from a classic American V8. GM 3.8-liter V6 engine. The GM 3.8-liter V6 engine, known for its long production run and use in various Buick and Chevrolet models, still ranks as one of the most failed engines due to persistent reliability issues, especially in the Series 2 variant. This engine struggled with coolant leaks, often caused by the plastic intake manifold gasket, which tended to deteriorate around 60,000 miles. When coolant leaked into the engine, it caused overheating and internal damage, leading to costly repairs. Additionally, the ignition system posed frequent issues, with coils and crankshaft position sensors prone to failure, resulting in misfires and no-start conditions. The engine also faced high oil consumption due to wear-prone piston rings, which degraded engine performance and necessitated frequent top-ups. While the 3800 V6 had a robust design in some respects, these flaws undermined its reputation, leading many owners to face expensive repairs. Despite its efficiency and initial appeal, the 3.8-liter V6 stands as a reminder that overlooked weaknesses can seriously impact long-term reliability. Saturn 1.9-liter inline-4 engine. The Saturn 1.9-liter inline-4 engine, used in the S-Series models, ranks as a worst engine blunder due to its notorious oil consumption and timing chain issues. A design flaw meant that the pistons lacked drainback holes, causing the oil control rings to stick and carbon buildup to accelerate, leading to oil burning at an alarming rate, often up to a quart every 1,000 miles. Regular top-ups became essential to prevent engine wear. Additionally, the timing chain, which relied heavily on adequate oil pressure, tended to wear prematurely if maintenance was neglected, risking catastrophic engine failure. Cracked cylinder heads were another problem, especially in the SOHC variant, allowing coolant to mix with oil and producing a chocolate milkshake effect that required costly repairs. Valve cover gasket leaks and EGR valve malfunctions further plagued this engine. Despite its simplicity, the Saturn 1.9 liters high maintenance needs and critical design flaws overshadowed its durability, cementing its reputation as a problematic and unreliable engine. Cadillac Northstar V8. The Cadillac Northstar V8, introduced with high expectations, ultimately became a worst engine blunder due to chronic issues that frustrated owners. Known for its innovative dual overhead cam design and impressive power, the 4.6-liter Northstar was quickly marred by frequent head gasket failures. The engine's torque to yield head bolts, intended to provide a secure fit, would often stretch and loosen over time, leading to coolant leaks, overheating, and eventually severe engine damage. Adding to the woes, Northstar engines were notorious for persistent oil leaks from various seals and gaskets, which became nearly inevitable by 70,000 miles. Repairing these issues was complex and expensive, as head gasket replacements often required the engine to be removed entirely. While Cadillac's limp home mode allowed the engine to run despite coolant loss, It couldn't mask the extensive maintenance demands and costly repairs. The Northstar's shortcomings ultimately left a tarnished legacy, overshadowing its early promise as a luxury performance engine and reminding owners of the high price of poor engineering execution. Rover K-Series engine. The Rover K-Series engine, introduced in the late 1980s, has gained a reputation as one of the most failed engines due to its frequent head gasket failures. Used in models like the Rover 200, MGF, and even the Lotus Elise, the K-Series' lightweight aluminum construction was innovative but fraught with issues. Key design flaws included an insufficient coolant capacity and plastic head dowels that couldn't withstand the engine's heat, leading to warped heads and blown gaskets. Often, coolant would leak into the oil system, causing overheating and severe engine damage. Early attempts to fix these issues, such as switching to metal dowels and implementing a multi-layer steel gasket, only provided partial relief. For many owners, head gasket failure became inevitable, often occurring as early as 30,000 miles. Despite its initial promise in power-to-weight efficiency, the K-Series' persistent gasket issues overshadowed its performance, making it a costly and unreliable choice that left many drivers frustrated. Suzuki 1.0-liter three-cylinder engine. The Suzuki 1.0-liter three-cylinder engine, found in models like the Suzuki Swift and Geo Metro, became known for its limited power and reliability issues. While designed as a compact and fuel-efficient option, this engine faced chronic problems that frustrated many owners. A frequent issue was rapid oil consumption, which, if left unchecked, led to overheating and eventual head gasket failure. Owners often reported seeing white smoke from the exhaust, a clear sign of coolant leaking into the combustion chamber due to a blown gasket. Compounding the issues, the engine was also prone to excessive vibration and misfires, especially at idle or when cold, which required consistent maintenance to keep it running smoothly. Although small and economical in theory, the engine's costly repairs quickly negated its initial low price. For many, the Suzuki 1.0-liter three-cylinder was a disappointing and maintenance-heavy engine, falling short in durability and power, ultimately phasing out amid widespread customer dissatisfaction. Subaru 2.5-liter turbo engine. The Subaru 2.5-liter turbo engine, widely used in models like the WRX and Forester, stands as one of the most failed engines in automotive history. Plagued by numerous design flaws, it became notorious for frequent head gasket failures, leading to coolant leaks, overheating, and expensive repairs. Another critical issue was oil starvation, caused by insufficient oil circulation, which could escalate into severe engine damage if left unchecked. The engine's excessive oil consumption was also a major complaint. Owners were forced to regularly top off oil, even in new vehicles, ultimately sparking class action lawsuits and government intervention. These recurring problems, including sudden power loss and engine stalling, severely damaged Subaru's reputation, highlighting why the 2.5-liter turbo is often listed among the worst engines ever produced. General Motors 2.4-liter Quad 4 engine. The Quad 4 engine, designed for models like the Pontiac Grand Am and Buick Skylark, quickly became notorious for its worst engine blunders. Initially intended to deliver high performance in a compact design, the engine faced a slew of issues that haunted owners. A frequent problem was the engine's tendency to blow head gaskets due to its high compression and aluminum cylinder head, which often warped or cracked under heat, leading to severe overheating and engine failure. Additionally, the Quad 4 was infamous for its excessive vibration, loud operation, and frequent oil leaks, making it uncomfortable and expensive to maintain. The ignition system, with no traditional spark plug wires, added further complexity, making even minor repairs a challenge. Despite numerous attempts by GM to resolve these issues, the Quad 4's reputation as an unreliable and maintenance-heavy engine remained. By the time it was discontinued, it had left behind a legacy of costly repairs and disappointed drivers, marking it as a lasting cautionary tale in GM's history. Volkswagen 2.0-liter TSI engine. The Volkswagen 2.0-liter TSI engine, found in models like the GTI and Audi A3, earned a place among the most failed engines due to several design issues that plagued owners. One of the most notorious problems was the timing chain tensioner failure, which caused the timing chain to slip or snap entirely, leading to bent valves, damaged pistons, and catastrophic engine failure. Early models also suffered from high-pressure fuel pump and water pump failures, both of which led to overheating and frequent stalling. The direct fuel injection design caused severe carbon buildup on the intake valves, affecting engine performance and requiring regular cleaning. Additionally, faulty ignition coils and fuel injectors led to frequent misfires, causing rough idling and poor acceleration. Volkswagen eventually made updates, but these costly issues led to class action lawsuits, and the TSI left a legacy of frustration and high repair bills, marking it as a prime example of failed engineering. There you have it, 25 of the most failed engines that left drivers disappointed and sometimes stranded. From ambitious designs that fell short to engines that simply couldn't keep up with the demands of the road, these engines serve as reminders of what happens when design and durability don't quite match up. So, what do you think? Do you agree with our picks, or did we miss an engine that deserves a spot on the list? We'd love to hear your thoughts and any stories you have about dealing with these notorious engines. Make sure to drop a comment below, hit the like button if you enjoyed the list, and share with fellow gearheads who love a good automotive breakdown story. And if you haven't yet, click to subscribe and stay tuned with Muscle Car Masters for more deep dives into the legends and lessons of muscle car history.